Here are the solutions to question 7. We are given a parabola with the equation y is equal to a bracket x minus 2 all squared plus q, passing through 2 points, negative 2 and 5, and 4 and negative 1. So in this case, we're not actually being given the vertex. All we're being given is 2 points. They could be anywhere on the graph, so please don't assume that one of them is a vertex. We actually have to determine what the vertex of the parabola is. So in a sense, we're actually trying to figure out what P, Q is. Now I'm going back to the equation that we've been given. We actually know the P value because we know our equation is x minus P. So that tells me P is equal to 2. We just don't know what Q is. We have another unknown variable in this equation, and that's A. Okay, so it seems like I have 2 unknown variables. There's no way I can solve this unless I actually have 2 equations. So that's exactly what we're going to do here. We're going to take this first x and y value and form our first equation. And then we're going to take our second x and y value to form a second equation. So we're going to be using a system of linear equation here to solve for this. But let me correct myself. These equations aren't necessarily linear, but they are systems of equations. Okay, so I'm going to replace my y value here with positive 5, which is equal to a, that's my first unknown, x, I know to be negative 2, minus 2 squared plus my first unknown value, second unknown value, which is q. Okay, now let's go to the second equation. Again, just replacing the x and y values here, y and x value in both. Now I've got a system, 2 equations, 2 variables. We have multiple ways of solving this. You can use substitution or elimination method. I'm going to go ahead and try substitution method here. And what I'll do is take my second equation, and I'm going to try to isolate q variable. So I'm going to write this equation in terms of q. And the reason I choose that is I can see if I wanted to isolate q, all I have to do is minus this term from both sides of my equation. So I get negative 1 minus a times 4 minus 2. I'm going to simplify that to 2 squared, which is equal to positive q. Let's simplify that a little bit more, and I'm going to move this to the front here, okay? I have negative 2 to the power of 2. That gives me 4. So negative 4a minus 1 is equal to positive q. Now my equation 2 becomes q is equal to negative 4a minus 1. And that's something I can use in my first equation as well. Reason being is that I know the q value is going to be the same in both scenarios, since this is all a part of one parabolic equation. So now I'm going to take my first equation again. I'm going to write out everything else I know, which is 5 is equal to a times negative 2 minus 2 gives me negative 4 squared. Negative 4 squared gives me positive 16. So I'm going to rewrite that as 16a plus q. Okay, so instead of q, this is where I replace my equation number 2 with q. That's going to be negative 4a minus 1. So I have 5 is equal to 16a minus 4a minus 1. That's something I can simplify, and the 5 and negative 1 can be combined as well. I'm going to move all of that to one side of the equation. The opposite of net minus 1 is plus 1, so I get 6 is equal to 16 minus 4, which is 12a. I'm going to isolate a here. That gives me a is equal to 6 over 12, which is equal to 1 over 2. All right, we now have one of our 2 unknown variables solved, and that is a. A is equal to 1 over 2. Great, now I only have one more unknown variable. We can go back to our original equation, use any of these 2 given points, and solve for q like you would in the other questions you've worked on this unit. Again, I'm writing out my original equation, but this time I've replaced a with 1 over 2 since we just solved for that. and I'm going to replace y with one of my points. I'm going to choose the first point here. 5 is equal to 1 over 2 times x. X value, we're going to change that for negative 2 since that's what's shown on here. Minus 2 squared plus q. 5 then is equal to 1 over 2 times negative 4 to the power of 2, which is 16. Let's multiply, not half and 16, plus q. That gives me q is equal to negative 3. Perfect. So that has helped us solve for the second unknown value. Now we know that q is equal to negative 3. Going back to the question here, the question is asking for the vertex of the parabola. So all I have to do now is write out vertex as a coordinate pair. My p-value is positive 2 and my q-value is negative 3. I hope that helps with the question. You also have enough information for a full equation here since we know that q is actually equal to negative 3. So you could plug this into your graphing calculator just to verify that the vertex is actually correct. Question 8 is rather similar to the previous one, but this time, instead of actually solving for the q value, it's asking you whether the function has a maximum or minimum value. So what you're going to be doing here is solving for the value of a. If it's positive, then we know that we have a minimum value. If it's negative, then we know that we have a maximum value. And it asks us to state the value. And remember that if I want to state the minimum or maximum value, that's asking us what y is equal to. Y is the q coordinate in our vertex since we have vertex is equal to p, comma, q. So yeah, we're going to have to do the same thing as last time, solving for a and q this time. Again, we start by forming a system. I'm going to take negative 6, comma 2 for my first equation, replacing y value with 2 is equal to a, my first unknown. X is negative 6 plus 5 to the power of 2 plus q. Let's go ahead and simplify that a little bit. 2 is equal to a times negative 1 to the power of 2, which is just positive 1, plus q. My second equation here, 20 equals a times bracket negative 3 plus 5 all squared plus q. Again, I'm going to simplify that a little bit. This negative 3 plus 5, that just gives us 2 squared, and that gives me 4. So I'm going to rewrite that as 4a plus q. So now you have two simple equations to work off of, and you can decide for this one if you would like to use elimination or substitution. I'm going to go ahead and use substitution again because that's the one I'm more comfortable with. But you can see in this equation is actually really good for the elimination method as well. I'm going to substitute equation 2 into equation 1. And to do that, I'm going to isolate q. Q is equal to 20 minus 4a. Taking my equation 1 again, I have 2 is equal to a plus, instead of q here, we're going to insert 20 minus 4a. I could put a bracket around there, but because this is a plus sign, it doesn't actually make a difference. Now we're going to try to simplify this. A and negative 4a gives me negative 3a, and opposite of plus 20 is minus 20, so I get negative 18 is equal to negative 3a. We're going to divide by negative 3 on both sides. That gives me 6 is equal to a. In other words, a is 6. There, I have a positive a value, so right away that tells me my parabola looks like this. So I must have a minimum. But I'm not done here, so I'm going to go back to my first equation with my x and y values in there, and I'm going to try to solve for q. Now, take a note that my original equation in that like y is equal to a bracket x plus 5 all squared plus q form is the same as this one that we've simplified. So why use the more complicated one when we can use the simple one? 2 is equal to a plus q, but instead of a here, well, I could use 6. 2 is equal to 6 plus q. So that means q must equal to 2 minus 6, which is negative 4. So my first thing told me that I have a minimum value. And my q value tells me what my minimum value is. Y is equal to negative 4. There we go.